Good evening, everyone. Am I audible?
Good evening, ma'am. Yes, you are audible.
Okay. So, welcome back to tutorial sessions on the course Principles of Organic Synthesis. So, this is the third week of our tutorial session. So, directly we can go. So, in the last week's lectures, we have seen basically acid catalyzed carbon carbon bond formation. And the major reactions which we have gone through was Mannish reaction, then Friedel-Crafts reaction, both alkylation and acylation, then Prince reaction. So, I will just give an idea about this so you can brush up what you have heard in the previous lectures. Then we will go to the problem solving session. So, Mannish reaction is basically the reaction between a ketone, a formaldehyde or any other aldehyde, and a secondary amine in presence of acid, followed by hydrolysis to give this beta amino alkyl carbonyl compound. Okay, so what is happening here is the condensation of an aldehyde or ketone in the form of an enol. So this ketone in the presence of a base will be converted into enol, and this aldehyde and secondary amine will react to form an iminium ion which will undergo condensation with the enol form of this ketone to get this beta amino alkyl carbonate. So the mechanism of this reaction is first this formaldehyde and our amine, preferably secondary amine in the presence of acid will form this iminium ion, and then parallelly the ketone in the presence of base or acid it can form this enol. So then this enol will attack on this carbon. Okay, so this enol, this nucleophilic attack will take place to form this carbon-carbon bond, and then this proton transfer from this oxonium ion to this nitrogen will take place to form the salt of this Mannish base, and then this OH minus will take up this extra proton which will form this beta amino alkyl carbonyl, which is a final product and that we call as a Mannish base. So last week also we have seen this reaction. So I hope everything is clear about the mechanism also. If there is anything which you are having doubt, you can ask. Okay, now moving to the next reaction, that is in next lecture we have seen this Friedel-Crafts alkylation and acylation. So Friedel-Crafts alkylation is basically both are aromatic electrophilic aromatic substitution reaction. So this aromatic compound in presence of an Lewis acid will react with this alkyl halides to give this substituted product that is known as Friedel-Crafts alkylation. And in Friedel-Crafts acylation, it will be reacting with this acyl chloride or acyl bromide, acyl halides generally in presence of this Lewis acid to get this acyl substituted aromatic compound, and this is known as Friedel-Crafts acylation. So going to the mechanism of this, first what is happening is that this aluminum trichloride, that is basically a Lewis acid, that will take up this that will coordinate with this chloride of our alkyl halide to form this activated electrophilic species, and then this AlCl4 will leave out as a stable compound and this carbocation will be resulting. Then yeah, that is the first step. Then what is happening is this carbocation, so we have aromatic compound as well, so it will undergo electrophilic attack on this carbocation, nucleophilic attack on this carbocation to get another carbocation which will then regenerate its aromaticity to get this compound. So this is Friedel-Crafts alkylation. Similar is the mechanism of Friedel-Crafts acylation. That is, from this acyl chloride, this chloride will first coordinate with this AlCl3 to form this activated species of electrophile. Then AlCl4 minus will leave out to form this acylium ion, which is another carbocation, or it will be existing in this oxonium ion form. Then this aromatic compound will undergo addition on this acylium ion to get this species, which will regenerate its aromaticity to give this acyl substituted aromatic compound. So this is basically Friedel-Crafts alkylation and Friedel-Crafts acylation. Then one another reactions which we saw was this Prince reaction. That is basically the reaction between an alkene, an aldehyde, and in presence of water it will be forming this kind of a diol compound in presence of acid catalyst. So that is basically Prince reaction. So here what is happening is that this aldehyde will first get protonated in presence of this acid to give this oxonium ion, and we have this alkene as well. This alkene will attack this positively charged carbon, this that is this what to say, this electrophilic carbon center of this carbonyl compound, and it will form this intermediate, and this carbocation will be generated, and this carbocation will be like stabilized by the water molecule which we are using as one of the reactant here. That is, water molecule will attack on this carbocation and it will form this 1,3 diol. So this is the final product of Prince reaction. In case if this is undergoing an elimination, this allylic alcohol can be formed, or if not water, any other nucleophile is quenching this carbocation, that can result in this 3 substituted alcohol. So these are the different cases, and we have also seen that this 1,3 diol further, if we are treating with an aldehyde, it will be forming acetal as a masking of this 1,3 diol. So different products are possible. So basic reaction is first the protonation of the aldehyde, and then this alkene will be attacking on that carbonyl carbon to form this diol. So these were the main reactions which we saw in last week's lectures: Mannish reaction, then Prince reaction, Friedel-Crafts alkylation and acylation. I hope it's clear. Maybe now we can move to the problems. So you can try answering these questions. So we have now discussed the mechanism in detail. So first you have to identify which reaction it is and then try to get the product. Predict the major product of the following reaction. So this ketone in presence of this formaldehyde and this dimethylamine and acid, what product we will be getting. Ishmi, this it's clear whatever I have discussed, all the mechanisms.
Yes, ma'am, it's clear.
Okay, you can try to answer this. Let me know whether you are able to reach the final answer. Otherwise, we will discuss. So, are you able to find which reaction it is? So this is basically managed reaction, and we have seen the mechanism now. So here what is first happening is that this formaldehyde and the secondary amine will react to form this intermediate, that is CH2 double bond NMe2, and this nitrogen will be having positive, that is iminium ion. So this is the first step in the managed reaction. The secondary amine will be reacting with this formaldehyde to form this intermediate. So this will be the intermediate in managed reactions in all case. Next, what is happening is that in the presence of acid, this particular ketone will form its enol. That is, here this phenyl group will be here, there, here this double bond, and this will be OH. So this is the enol form of this ketone. Then next step what is happening is that this, yeah, this lone pair will come here, and then this double bond will go and attack this carbon, and this bond will shift to here to stabilize the positive charge on nitrogen. So what, that is what is happening. So we will get pH, C double bond O will be coming back here, and then this CH2, then this CH2, and then NMe2. So this is an example for managed reaction. Is it okay? So anytime you are seeing this secondary amine and a formaldehyde, first intermediate which should come to our mind is this one. And then if there is an enolizable proton or a carbonyl compound which can form enol, that will form enol in the presence of acid or base. So in managed reaction, we are using acid. And then that enol will attack on this carbon of this iminium salt, and that iminium ion will be stabilized. So we will get this compound, beta amino alkyl compound. So moving to the next question, the major product of the following reaction. So here there is an alpha beta unsaturated carbonyl compound, then there is a free alkene in presence of trifluoroacetic acid and K2CO3. What will be happening? So first step we are using an acid, and in second step we are using a base. You can try out of these four options which will be the major product. So this is the a modification of Prince reaction, we can say, and the answer is this one, that is option B. I hope you are able to get to this answer. I will explain. So first, what is happening is that in the presence of this acid, this double bond will attack on this center, so that this one, two, three, four, five, six, a six-membered ring will be formed, and this double bond will shift to here, and it will be taking up a proton, so that it will be a six-membered ring with this CH2CO2 over here. That is this substituent. And then what is remaining is that since this double bond attacked here, a carbocation will be formed at this position, that upon workup or in the presence of this K2CO3, which will be also in aqueous medium, that will give one OH minus, and it will form this compound. That is, this carbocation is stabilized by this hydroxide ion. So that's how we will get this product. So this, we can say, it is not typically a Prince reaction, but it's a modification of the Prince reaction. First, this double bond will attack at this center, and this double bond will take up a proton to form a six-membered ring with a CH2CO2 substituent at one side, and this carbocation, which is resulting, will be quenched by this hydroxide ion. Now, moving to the next. In between, if you are facing any difficulties or any doubts, you can ask anytime. Moving to the next question. Predict the major product of the following reaction. This particular compound in presence of this we will say para formaldehyde. For this is basically a polymer of the formaldehyde, and this bismuth triflate and acetonitrile solvent under RT condition, which will be the major product. So here this bismuth triflate is basically a Lewis acid. So acid is there, aldehyde is there, alkene is there. So this is also another example for Prince reaction. So if you are taking the one molecule of paraformaldehyde or one molecule of formaldehyde, this is the structure of formaldehyde. And so first this bismuth triflate will do is, being a Lewis acid, it will be coordinating with this oxygen of this carbonyl group as bismuth triflate. I am not writing the full part. So next what is happening is that this alkene will be attacking this carbon to form here CH2, and one carbocation will be generated at this center, and then CH2COH will be forming. Then again this carbocation, as we saw in earlier cases, this will be stabilized by one hydroxide ion to form a diol. So what is the first product is that benzene ring here, OAC over here, then CH2, where the carbocation is forming initially, that will be stabilized by this OH ion, and then one carbon, next carbon, and one more OH. So first this will be forming, but since we are using this paraformaldehyde, many molecules of formaldehyde will be in the reaction mixture there. So whatever diol is forming here, this is basically a 1,3 diol. It will be getting protected by this formaldehyde as an acetyl group. So here this HH will not be there, and here this will be like this. This proton will not be there, this proton also will not be there. So the answer will be this one. So this is another example of Prince reaction. So what is happening basically is that first this formaldehyde molecule will be coordinating with this Lewis acid bismuth triflate, and then this alkene will be attacking at the carbon of this carbonyl carbon, resulting a carbocation at this position, and here OH will be forming. Then this carbocation will be again stabilized by hydroxyl ion to form this diol. That is, this one will be forming first, but since we are using paraformaldehyde, there will be excess of formaldehyde molecules in the reaction mixture. So that will protect our compound, protect this diol, and it will be forming this compound. That is, this 1,3 diol will be protected as this acetal by using formaldehyde. So this is also an example for Prince reaction. I hope it's clear. Now moving to the next question. Predict the major product of the following reaction. So this is also similar reactions, and we have seen all this in the lecture videos as well. So this biphenyl derivative in presence of this formaldehyde and this dimethylamine, which is a secondary amine, and in presence of an acid. Out of this four, which will be the major product? Anyone can answer as well. First, you can try. First, you can identify which reaction it is. If you are interacting, it will be helpful to you as well as me.
Reaction.
Manage reaction, yes. So we have already seen the mechanism, right? So I will once more write the intermediate here. So this formaldehyde along with that secondary amine will be forming this intermediate first, CH2 double bond NMe2 plus, and then in the presence of this acid, what will happen is that this double bond will shift to here, and this oxygen lone pairs will shift to here, and this double bond will be attacking our carbon, and this will shift to here to stabilize.
Ma'am, C option.
Option C, yes. So mechanism is clear, right?
Yes, ma'am.
Okay. Now moving to the next question. So the answer is option C. So again one more same managed reaction, the major product of the following reaction. So this is 2-methyl pyridine. We are treating under this managed condition.
Is it option D?
Yes, option D. So how it is happening actually?
Ma'am, firstly, the lone pairs of um, Like the carbon just uh, the nitrogen carbon and this methyl will have the double bond.
Yes, yes.
Yes, ma'am. This
Yeah. So this nitrogen will be
then this
probably,
double bond will attack
yes.
on the intermediate formed.
So this will be the intermediate, right?
Yes, ma'am.
Here N plus will be there. And this double bond will be attacking on that. Our whatever intermediate iminium ion will be formed. This double bond will be attacking on
Yes.
that. Yes. So answer is option D. Next question. Yeah, again one minus reaction. Here we have indole. So into
Ma'am, the option B.
option B. Yes. So how it's forming?
Again, the lone nitrogen will shift there, and that double bond will attack on the intermediate formed
Yes.
from the
Double bond.
formaldehyde and that.
Yeah. And then
Yes, ma'am.
this indole will regain its aromaticity.
Yes, ma'am.
Okay. Yeah. So this is the answer option B. Now next is this one. Predict the major product of the following reaction. This particular, so this is having two alkenes. Then in presence of formaldehyde, BF3, acetic anhydride and DCM, which will be the major product.
Ma'am, option C.
Option C, yes. So which reaction it is?
It's Prince reaction.
But it's not actually option. I think first it is forming that only. Um,
Yes.
then option C will be forming when this will be like the carbocation whatever it is forming will be quenched by H plus, right? Like this will be attacking this carbon, and as a result of that, a carbocation will be formed at the center, right? That is the mechanism of Prince reaction.
Yes, ma'am.
So
Yes.
this will be forming when this carbocation, whatever it is forming here, is quenched by a proton. But our answer is this. So what is happening is that we are using acetic anhydride, right? So this
Yes, ma'am.
carbocation will be
Yes.
first quenched with this acetic anhydride. That OAC will be getting, like OAC will be attacking at this center. Then elimination is taking place actually as one acetic acid molecule to get this compound.
Okay, ma'am.
Is it okay? So first here OAC will be coming, then one proton from this methyl will transfer to there and acetic acid will be leaving to form this alkene.
Okay, yes, ma'am.
And why this double bond is not reacting? Why this is more reactive? One reason we can say this is free because it's not inside any ring. That is one reason. Then another reason we can
Okay,
say is this is less substituted double bond, right? This is more substituted double bond. So more substituted double bonds are more stable. It will be less reactive.
okay, yes, ma'am.
Yeah. Moving to the next question. Here is the mechanism of that. This is Prince reaction. So we can tell the mechanism is oxo-ene mechanism. That is first BF3 will coordinate with this formaldehyde, then alkene will be attacking here, and then as we said, this acetic acid molecule will be eliminating to get this compound. So this is the next question. Predict the major product of the following reaction. So here also two alkenes are there. Then this ketone is no aldehyde is there, and then BF3 iterate is there, which is also a Lewis acid.
Ma'am, is it option B?
B or D? We'll see. Yeah, it's option B. B only you answered, right?
Yes, ma'am.
Okay, so what is happening here?
Ma'am, I can predict the product from the carbon adjacent with oxygen, but I don't know how TMS is leaving from there. Can you please
TMS is,
explain
yeah,
that
I
point?
will explain. TMS is actually a very good leaving group. That is trimethyl group, right?
Yes, ma'am.
So this carbon and
Yes,
that
yes.
silicon bond is not that much strong. So it will easily get removed. So first what is happening is that this aldehyde will be coordinating with our Lewis acid, that is
BF3 blue acid.
yeah. Then this TMS will leave and this bond will be shifting to here and this will attack over this sender and then this alkene will be attacking on this carbon.
Okay, yes, ma'am.
Okay,
Fine.
so that's how we are getting this product. So this is that pathway. This aldehyde will coordinate with BF3 therate. This bond will shift here. This will attack over here, and this alkene will attack at this carbon center. This is also a type of Prince reaction.
Yes, ma'am.
Yeah. Next question, the major product of the following reaction. So here, this aromatic compound is there in presence of this terbium triflate. That is also a Lewis acid, and this toluene is not toluene. Benzyl chloride is phenyl chloride. That is, yeah, it is the solvent. So are you able to find out which reaction it is?
Ma'am, it's again Prince reaction, but I think intramolecular is
This is not
this.
Prince actually. This is like Friedel-Crafts, we can say Friedel-Crafts acylation, but intramolecular.
Yes, ma'am,
Yeah.
intramolecular reaction.
So which will be the product here?
Ma'am, is it C? C option C?
C. Okay, you can explain how you got C.
Ma'am, this is the carboxylic acid
Yeah.
where the Lewis acid will be getting coordinated with the
Yes.
oxygen
Yeah. Yeah.
and the carbon will be more electrophilic in
Yes.
this case.
Yeah.
Then one of the, yes, this double bond will attack on this carbon
Yeah.
like this.
But how this double bond is forming? This is
Ma'am,
nice.
I thought,
You thought maybe
okay,
that OH is not like this is also
yes,
carboxylic acid, right? So you thought maybe water molecule is getting eliminated, right?
yes, ma'am.
That is not what's happening here. So this double bond will attack at this carbonyl center, and OH is leaving as such.
Okay,
Okay, because it is in the form of a carboxylic acid, not like a hydroxy substituent, right?
okay, okay,
Yeah. So this is
okay, ma'am.
yeah. So it's basically intramolecular Friedel-Crafts acylation, we can say.
Yes,
Yeah. Now this question: predict B in the following reaction sequence. So first is this ketone. So this is clear what will be the product A, this managed reaction product. Then again we are treating it with this methyl iodide and this hydroxide ion. So we have to find out what will be B.
Friedel Craft alkylation is this, na?
What will be this? See this substituents.
Ma'am, this is manic reaction.
But for Friedel-Crafts, what we need? Friedel-Crafts is basically electrophilic aromatic substitution, right? So we need aromatic substituents.
Okay.
So what will be the A product? So first that managed reaction product will be here ketone and here this carbon.
One carbon and an NME2.
Yeah, NME2 will be there. And here also ketone will be there, right?
Yes, ma'am.
Yeah. So here what is happening is that first this is forming as a result of managed reaction. Then in the presence of methyl iodide, it will form this quaternary ammonium salt, we can say. That is this nitrogen will again take this methyl group and it will exist as this salt. That we will
Hmm.
say like this Eschen-Moser salt you have heard. It's
Yes, ma'am.
yeah,
But I
managed
don't
salt.
remember.
Yeah, yeah, fine. So once this managed product is forming, again it will take up the methyl group and that will be existing as salt that we will say managed salt. Then this is highly like prone for living. That is, it's a very good living group. So what will happen is that one proton it will take, and that bond will shift here, and this will leave out. So we will be getting this one. In presence of this base will take this proton, and this will also get eliminated. Okay, so option is the answer. Is it clear?
Okay, ma'am. Water is getting eliminated.
Like we are already using this hydroxide ion, like one base we are using, right? So
Yes,
that
ma'am.
base will be taking this proton and it will remove us water, and this will get eliminated. That is, this NMe3 plus and this I minus will be getting eliminated.
Okay, ma'am.
Yeah.
Yes, ma'am.
So it will result in this alkene. So that's the 10 questions. Now I have also added that our week 1 assignment. Maybe we can discuss that also. Due date is already over. So that will be basically about our aldol type of reaction, that is base catalyzed reactions mostly. So this is the first question. Major product of the reaction. So here is one aldehyde and this nitro compound in presence of piperidine, which is a base, and toluene as the solvent.
Solvent.
So here we are using base, right? So from which position first proton abstraction will be taking place?
Ma'am, from the activated methylene group that is just adjacent with nitro group.
Yes. So we can tell carbanion will be generated at the center. Then what is
It
happening?
will attack on the carbon of this aldehyde. Yes,
Yeah,
ma'am.
and that will be converted into alcohol, right?
Yes, ma'am.
So answer will be option B. Now the next question, the major product of this reaction. Here this is a diketo compound in presence of 2% NaOH ethanol.
Ma'am, option C.
Yes. So from where first proton abstraction is happening?
From the carbon right side to the carbon.
Like here, right?
Yes.
Okay. So this will attack at the center and that will get
Yes, ma'am.
converted into OH. Then what is happening? Condensation is happening. That is, water molecule will get eliminated to form this double bond. So this is the answer, option C. Now next question, major product of the reaction. So this carboxylic acid in presence of benzaldehyde, acetic anhydride and triethylamine.
Ma'am, it's option D.
Yes. So here also aldol, right? First proton abstraction.
Ma'am, please explain its mechanism. Actually, when I was watching the video at that time, also I didn't understand that.
Okay, so we have here benzaldehyde, right, as other substrate. That is this aromatic ring, double bond O and H. So this whatever a carbanion is generating at first, that will attack at this carbon center and it will be forming this O minus, right?
Yes, ma'am.
Okay, so then it is basically an aldol condensation reaction. So if we are not heating also in presence of this acetic anhydride triethylamine, there is a possibility of elimination of that water molecule. Like we will be getting this here OH, then this carbon, and that will be having another aromatic ring, and here this carboxylic acid. So this will be the first aldol product, right? Then again,
Yes, ma'am.
yeah, again this proton will be acidic, so it will again get eliminated as proton, and this OH minus also will leave to form this double bond over here. So that is this one.
Ma'am, this is okay, but how to react with acetic anhydride?
Acetic anhydride we can
But
say
how acetic anhydride is
involved
acting
in the
on the
reaction,
on
right?
the
So since this hydroxyl group is here, this triethylamine can take this proton of this hydroxyl group. So it will be basically O minus, right? Then that O minus will be attacking on the acetic anhydride and that will be OAC. That is O C double bond O CH2. That's fine. So basically, this compared to this hydroxyl group, this acetate is a good living group. Acetyl group is a good living group. So first, this hydroxyl group is in situ getting converted into this acyl compound, and then this actually it is not the elimination of water molecule; it is the elimination of acetic acid. Is it okay? So this OH will be converted
ma'am, that
to AC. Yeah, yeah, yeah.
means that means the acetic anhydride is firstly uh, attacking on benzaldehyde.
No, no, no. Once we get this aldol product, right?
Okay.
Like this carbanion will be attacking on this benzaldehyde, then here this O minus will be forming, right?
Yes.
That O minus will be attacking on that acetic anhydride to form this OAC.
Okay.
Ah, then that OAC and this proton will be leaving as acetic acid to form the double bond at this position. So this will be not OH, it will be remaining in situ as OAC. Like whatever oxonium ion is forming, that will be trapped by the acetic anhydride.
Okay.
So
Okay,
that
ma'am.
aldol condensation will be favored, acetic acid will be leaving out as a stable molecule. So other cases we have seen we have to heat it, the reaction mixture, right? Mostly we have to heat the reaction mixture for this condensation to take place.
Yes, ma'am.
Or in some cases it should be highly sterically hindered system for that water molecule to get eliminated and form their more substituted double bond. That is another case. Then one another case is this one. If we are using acetic anhydride in that aldol reaction condition, there is a possibility of elimination as acetic acid. Okay, these three are
Okay,
the
ma'am.
cases where aldol reaction will not stop at that stage. Further aldol condensation can also take place. It's clear?
Okay, ma'am. Fine. Yes, ma'am.
Yeah. Okay. Now this one, the major product of the reaction. So this is an active methyl compound and this 1,4-dibromo compound. First we are treating with this excess of sodium ethoxide, then NaOH and hydrolysis followed by heating. So are you doing MSc or?
Ma'am, I have completed MSc.
Okay. So you're trying for PhD or job?
Ma'am, for job
Okay.
only.
So what is happening here? So first this base will be taking up this proton that will be attacking at this center in a SN2 fashion and this bromide ion will be leaving out. So that will be the first intermediate. Then again, since this is a highly acidic compound, again one more proton will be present here and that will also get eliminated and form that carbon ion like in enol form, and that will attack again this center and one more bromine will be leaving out. So we will be getting this four membered ring, and here CO2Et, here also CO2Et. So this will be the product resulting from the first step, right? Then in the second step, when we are treating with this NaOH in presence of this aqueous NaOH, that is hydrolysis, this both this ester will be converted into corresponding carboxylic acid. So it will be a dicarboxylic acid. Then upon heating, one molecule of carbon dioxide will be eliminated and we will be getting this as the product. So first this aldol product will be forming, then NaOH hydrolysis, basic hydrolysis will convert this both into carboxylic acid. Then in presence of heating condition, this carbon dioxide will be leaving out and we will be getting this product, option B. Is it okay?
Ma'am, in this reaction, why don't uh, both of the carboxylic acid escape as CO2?
Like it's possible, but we can control this reaction. Like when this
Okay.
dicarboxylic acid is there, that is at same center, we can control actually this reaction and stop the reaction at that stage where one molecule is only getting eliminated. And for both removal we need more harsh conditions, maybe that mild heating will not be sufficient because this dicarboxylic acid will be highly sterically hindered system, right?
Yes, ma'am.
So there is always a tendency, if we are heating it mildly also, one molecule of carbon dioxide will be eliminated to form this compound.
Okay, ma'am.
Yeah. Then the major product of the reaction, here is a ketone and here one aldehyde. So presence of base and methanol. Which one will be the product? What will be the answer? So here,
Ma'am,
yeah, yeah, tell me.
it's option C.
Option C. So you are expecting um, like this internal double bond is forming, right? How it will be forming? Because once this is attacking over
No, ma'am. Yes, external double bond should be formed. Option B is it.
option B, yeah. So OH will be at this center, right?
Yes, ma'am.
Then water molecule will be leaving to form double bond here.
Yes, ma'am.
Yeah. Next one, the major product of the reaction. So this aldehyde, this keto compound, and this diester we can say in presence of pyridine and tin chloride. So here also we have to see which one will be more acidic from where proton will be abstracted first.
Um, Ma'am, the hydrogens which having the carbon having those hydrogens which is between those
Yeah.
carbonyl.
Yes.
Yes,
This
ma'am.
will be more acidic, right? It is an active
More
methyl
acidic.
compound, yeah.
Active methylene
Then
carbon.
this will be attacking over here.
This will attack this. So the option B is correct, ma'am.
Option B, yes. Next one. This is also another aldol reaction.
Ma'am, option A.
Yes. So this is also simple reaction, right? Here carbanion will
Yes,
be
ma'am.
generated, retinol will be attacking here, and one OET will be leaving out.
Removed.
Yeah,
Yes.
option A will be the answer. Next is this one. So this will be intramolecular reaction.
Ma'am, I think it's option C.
Option C. No, it's option D. So where that
D.
hydroxyl will be
Okay.
forming? Am I audible now? Too much noise is there. So from where this proton abstraction will take place?
Yes, from here, ma'am.
Yeah. So this will attack at this carbonyl center. So it will be like,
And seven-membered ring.
yeah, 7 membered ring, and here 5 membered ring will be formed. Right. Here only thing we have to think is that there is both the possibilities, like OH will be at the center, right? Where OH will be.
Yes, ma'am.
Yeah. So this will be the most stable double bond, or this will be the most stable double bond.
The double bond is more stable in the larger rings.
Larger ring also and more substituted also, because here there is one substituent only
Okay.
at this center and two substituent at this center, but in this case both sides are di substituted, right? So this is a tetra substituted double bond, this is a tri substituted double bond.
Okay, ma'am.
So in normally if there is no steric hindrance or anything, every time this more substituted double bond will always be preferred over less substituted ones.
Okay, ma'am.
Okay, yeah. So answer will be option D.
Yes, ma'am.
Next one is major product of the reaction.
Ma'am, it's option D.
Option D. Sure.
B, B, B.
B, B, yes.
B.
Yeah. So it's clear, right? First aldol is taking place from this
Yes.
center, and then, yeah, stereochemistry is clear.
Yes, ma'am.
Okay. Already we have discussed this type of problems in lectures 1 and 2. Yeah, and this is the last question for today. So here is one ester. Here is this nitrile compound.
Ma'am, it's option D.
Option D or B? D. Yes, it's option D.
D.
Yeah. So from here, first proton will be taking, right?
Yes, ma'am.
Yeah. Then it will be attacking at this carbonyl carbon, and that OMe will be leaving. Okay. So this
Yes, ma'am. Option D.
PMP is just this paramethoxy phenyl group.
Okay.
Yeah. That is this whole thing they have given as PMP, paramethoxy.
PMP. Okay, ma'am. Phenyl.
Yeah. So that's all for today. Thank you for joining. If you have any doubts, you can ask.
Ma'am, it's okay as of now.
Yeah. So we will see you next week then. Thank you.
Thank you so much, ma'am.
Thank you.